What if I told you that everything around you, from the clouds in the sky to the bubbles in your soda, is following secret instructions written in the language of physics? Think about it. Why are soap bubbles always round? Why does milk create those beautiful swirls in your coffee? Why does mud crack into geometric shapes when it dries? Here is the secret. Liquids are crazy. They always choose the easiest path, the one that uses the least energy. And when they do that, they create patterns. Scientists call this self-organization. I call it nature being a lazy genius. Hello, I'm Vinod Babasaheb from IIT Guwahati. For 5 years, I have been tricking liquids into building blocks, microscopic structure that could change the world. Modern technology runs on patterns smaller than a grain of dust. Medical test strips, computer chips, water filters, sensors. Making these patterns requires expensive machines and massive energy. But nature already knows how to build perfect patterns effortlessly. Snowflakes, honeycombs, Saturn rings, zebra stripes. So, my research asks, can we let nature do the engineering for us? Imagine a liquid surface as a playground where invisible forces fight. Gravity pulls down, surface tension pulls tight, pressure pushes outward, and molecular forces pull from within. When these forces compete, the surface becomes unstable, and instability, that is where patterns are born. I study this in film thinner than a human hair. Two liquids stacked like a sandwich. The place where they meet, the interface, is where the magic happens. In my first experiment, I placed a water drop onto a thin liquid film. Instead of spreading smoothly, tiny fingers appeared. They grew, they branched, they connected. Under the microscope, they looked exactly like flowers. No printing, no machines, just physics. Why it matters? The flower structure is full of perfectly sized holes. Imagine a water filter where the holes arranged themselves. Cleaner water, faster filtration, lower cost. A tiny flower grown in my lab could one day provide clean water for millions. Next, I worked with liquid crystals. The same material inside your phone screen. I placed one droplet on water, next to it a droplet of hexane, a liquid that evaporates instantly. As the hexane evaporated, its vapor hit the liquid crystal droplet. This changed the surface tension on one side, and result? The droplet started moving all by itself. No motor, no push. Twin vertices spun inside it like a double tornado. The front edge stretched thin, grew fingers, and those fingers snapped into hundreds of tiny droplets. These tiny droplets could become drug carriers. Inject them into your body, and they swim to exactly where medicine is needed. A cancer cell? Deliver the drug right there. No side effect elsewhere. Tiny robot doctors made by just evaporation. For my thinnest experiments, films so thin you would need a million stacked to equal one paper sheet. Gravity becomes useless. So I used invisible forces. I applied an electric field horizontally across a thin plastic film, then a magnetic field pointing outward. When electricity flows through a magnetic field, it feels a push. It's called the Lorentz force. It makes electric motor spin. It makes your washing machine work. In my film, this invisible push created competition. Some regions rose, some fell. They fought until they found the most stable arrangement. What emerged? A perfectly ordered microscopic city. Thousands of tiny pillars, evenly spaced, self-organized. Today's computer chips are carved in billion-dollar factories. What if you could just paint a liquid, turn on fields, and let the pattern grow itself? Cheaper, faster, and greener option. So let me connect the dots for you. Gravity gave me microscopic flowers that can filter water. Evaporation gave me self-splitting droplets for targeted medicine. And invisible forces gave me microscopic cities for future computer chips. 3 different tricks, one big idea. When you understand how liquids behave, you can make them build anything. The bubbles in your soda, the swirls in your coffee, the cracks in drying mud. They are not just random patterns. They are nature speaking a language of lazy liquids finding the easiest path. My PhD was about learning to speak that language, and I'm just getting started. Next time you see a bubble or a swirl, pause. Wonder. Ask yourself, what's the lazy liquid trying to tell me?